It's time to learn about the hidden science in our lives. Today's topic: 3D printing. Usually, we print documents or drawings from our computers on paper using ink. This is known as 2D, or two-dimensional printing. 3D printing, on the other hand, is a technology that creates three-dimensional shapes from digital 3D models. Various materials such as metals, plastics, and ceramics can be used. And these materials are layered on top of each other, a process often referred to as additive manufacturing. The basic concept of 3D printing has been proposed since the 1940s. It wasn't until 1988 that the company 3D Systems in the United States launched the world's first stereoscopic 3D printing equipment. Currently, 3D printing technologies are actively applied in the fields of aviation, automobiles, and medicine all around the world. With the ongoing development of various 3D printing technologies and materials, the fields to which 3D printing can be applied are also expanding rapidly. As mentioned earlier, while conventional manufacturing processes can be described as whittling away at something, 3D printing processes involve layering things. There are 7 different types of 3D printing technologies, which are characterized by their own unique lamination methods. Depending on these methods, various materials such as metal, plastic, biocells, and food can be used in the lamination process. Among these different types of materials, today we will explore metal 3D printing technology, which has had the largest industrial impact. The Department of 3D Printing in the Advanced Manufacturing Systems Research Division at the Korea Institute of Machinery and Materials is developing metal 3D printing equipment using PBF and DED methods. The PBF method is a method of manufacturing three-dimensional objects by adding metal powder materials layer by layer and shooting a laser to the desired area to create a given shape. Since PBF can create shapes at once that are otherwise impossible with conventional machining, it has several advantages such as performance improvement, weight reduction, and reduction of the number of parts. The DED method shoots a laser on metal surfaces and simultaneously supplying metal powder to the melted areas, while moving the lamination head to laminate the desired parts. Due to its relatively fast lamination time and its applicability to large parts, this technology is used to repair damaged parts and to strengthen surface performance by laminating materials superior to the original materials. In which fields might such 3DP technologies be applied? First, aerospace parts. They can be used to create light and high-performance parts with structures that cannot be made through conventional processing methods. Second, national defense and military parts that are resistant to wear, tear, and corrosion, so that they can be used in harsh environments. Third, medical parts that are customized for individuals and inserted into the human body, such as artificial teeth and bones, and even everyday objects, such as bicycles and ice hockey sleds. Indeed, with such 3D printing technologies, the fields of application are endless. The Korea Institute of Machinery and Materials Department of 3D Printing, the only department within the government-funded research institutes in Korea that directly researches and develops core modules and equipment for 3D printing. Researchers in this department are developing industrial and national defense parts, as well as new magnetic 3D printing technologies for next-generation motor technologies. Sometime in the future, the team hopes to achieve the capacity for flight using urban air mobility, which is characterized by a lightweight structure and a high-performance motor made by metal 3D printing technology.